So the next transformation we're going to talk about are something called rotations. Now, rotation is something where we're rotating the object, kind of like a wagon wheel or the hub of a wheel, there we go, around something. So if you think of it, we're going to have a center of rotation, and when we're rotating an object, we're kind of rotating it from one point at a fixed distance to another point, another fixed distance. Now, does this preserve orientation? So if I take and I rotate an object like A, B, C, right? And if I rotate it, and if I'm rotating along a wagon wheel kind of thing, so let's go ahead and copy and paste this, then what's going to happen is it's actually going to rotate, and it's actually going to rotate kind of along here. Now either way, and what that means is it's going to have the same equal distance of each of the points from a center point, that's the rotation. If you look at this orientation, this is ACB. Remember, always clockwise. And then we started ACB here, even though this is the prime, right? So it's A prime, C prime, B prime. So yes, it does preserve orientation. Is it isometric? That is it rigid? Yes. Okay. Now, when we're doing rotations, we're going to be doing rotations on coordinate planes, and we're going to be doing them about the origin, and we're going to be defining counterclockwise as positive. So that's a positive rotation. And that would mean that if we're changing directions, going clockwise, right, that would represent a negative rotation. Now we're going to be doing multiples of 90 degrees. So if I rotate counterclockwise 90 degrees, right, starting from here, 0 to 90, then I go another 90, that would be 180. Now if I go another 90, that would be 270. So there's an equivalence. And by the way, if I go all the way around, that's 360, right? Clockwise, if I were to go negative 90, right, then that would be here, would be the same as a positive 270, or clockwise, right? And then if I go a negative 180, well, those are the same, and a negative 270, okay? The center of rotation for our purposes is going to be the origin, okay? We're going to be using that exclusively from the origin. Rotation notation. Little r is reserved for reflection, so it's capital R. And we're going to be focusing on R90, R180, and R270, all of which are counterclockwise rotations, and then the corresponding clockwise rotations would be R270, negative 270, R negative 180, and then R negative 90. What this means is, and you're going to be expected to know these different formulas, is that you don't need to know as many. You only need to know 3 because there's corresponding clockwise and counterclockwise. Let's label that. So that's counterclockwise versus the clockwise rotations. Okay? So these are the ones to memorize. Rotation of 90, which is the same as an R rotation of negative 270, right? Counterclockwise 90, clockwise, right? So this is counterclockwise, this is clockwise, counterclockwise, clockwise, counterclockwise. You get the picture by now, I hope. Opposite yx, opposite x, opposite y. So they exchange positions, opposite. Think of that as an opposite sign, opposite, because it's changing the sign of the original. What is negative becomes positive, and what is positive becomes negative. If it does not have anything in front of it, it stays the same, meaning if it was already negative, it's going to stay negative. We'll look at some examples here. How does now sound? Okay, so what we're going to do is we're going to set up a rotation, and we're going to choose a point as the center, which is going to be the origin, like I said, and we're going to select that object, and we're doing a rotation of 90. Now this thing does indeed 90 degree. Look at that. So if I were to take a look at the distance from one point to the other, now if we take a look here, by the way, if this is C prime, right, it's got some distance from that center, yes, and it's been rotated 90 degrees. So what point would that be? Well, it would be this point here would be C prime, okay? And if you look at that, that is indeed 90 degrees. Take a look. Up 2 over 4, over 2, up 4. This is going to be the same distance. And likewise, because it's a rigid transformation, we're going to see that A prime is going to move here, and then B prime will move here. And to illustrate what we're talking about the whole R90 is XY becomes opposite Y X. This point B is at 1, 2, 3, 4, 5, 4. Right? This point A is at 3, 4. This point is at 4, 2. What are the corresponding points at? Well, let's change our color here to that. That's good. A prime is at -4, +3. C prime is at -2, +4. And B prime is at -4, +5. Then let's take a look. A was 3, 4, and became A prime at -4, 3. Did these switch spaces? Yes. The 4, which is originally positive, became the opposite, or negative. Okay? So that's how that works. And if you follow through with all the rest of the points, it's the same thing. Let's take a look at another example, but let's make it a little bit more complicated. And that will be to take this thing and move it down here. Now I'm doing another 90-degree rotation, but let's do this. Let's go ahead and axe that rotation. Let's do another rotation. And let's do the centered about the origin. And let's do a rotation of 270 degrees. And apply it to that. There we go. So what's actually happened is this thing has started here. Right? Here's A. And it's gone 90, 180, and then 270 around, which I would argue means that this must be A prime. Well, let's take a look. A is at 2, -2. And we know that an R270 on XY is similar, but it's Y opposite X. So the original Y, right, so that should be, if we do an R270 on 2, -2, the original Y goes up front unchanged, and the original X, which is 2, then becomes the opposite sign, so -2, -2, which is what A prime is. Let's try a little bit more complicated one where the numbers are a little bit different. Let's take a look at C, which is at 3, -1, 2, 4, which means that C should become what? Y comes first, unchanged, so still a -4 because it started -4. 3, which is the X, becomes the Y and becomes the opposite sign, so 3. So -4, -3, sure enough, this is C prime. Okay? And so that, as they say, is that, how that works. Okay? So hopefully that helps you with rotations.